The topic for today's discussion is isomerism. Compounds that have same molecular formula but different spatial arrangement of atoms or group of atoms within the molecules are called isomers, and the phenomena is called isomerism. Isomers have different chemical and physical properties. For example, butane. Butane has molecular formula C4H10. It means it has 4 carbon atoms and 10 hydrogen atoms in it. There are two isomers of butane, and butane and 2-methyl propane. Both has molecular formula C4H10, but they differ in their structural formulas. The next one is isomerism. Isomerism are of two types, structural isomerism and stereoisomerisms. Stereoisomerisms are further classified as geometric isomers and optical isomers. Geometric isomers differ in their spatial arrangement about double bond. For example, in cis-2-butene, two methyl groups are present at the same side about a double bond, whereas in trans-but-2-ene, two methyl groups are present at the opposite side about a double bond. In optical isomerism, they differ in their arrangement of atoms in 3D space, which create mirror image of each other's. Example, enantiomers and diastereomers. Today, we will discuss about structural isomerism. Structural isomers or constitutional isomers are the compounds that have same molecular formula but different structural formulas. Chain isomerism have same molecular formula but differ in the order in which carbon atoms are bonded to each other. Here again I have taken the examples of butane with molecular formula C4H10 but different in order in which carbon atoms are arranged. In N-butane, carbon atoms are arranged in straight chain, whereas in 2-methylpropane, carbon atoms are arranged in branched chain. Next example is of pentane. The next one is position isomerism, which have same molecular formula but differ in the position of a functional group on the carbon atom. For example, in 1-chloropropane, the functional group chlorine is attached at position number 1, whereas in 2-chloropropane, the functional group chlorine is attached at position number 2. Another similar example is of alcohol. The next one is functional group isomerism. Functional isomers have same molecular formula but different functional groups. In propanol, there is the functional group is aldehyde, whereas in propanone the functional group is carbonyl compounds, but they have same molecular formula. Similarly, ethanol and methoxymethane are the examples of functional group isomerism. The next one is metamerism isomerism. This type of isomerism occurs due to unequal distribution of carbon atoms on either side of functional groups. For example, diethyl ether and methyl propyl ethers are metamers. In diethyl ether, there is presence of 2 carbon atoms on either side of oxygen atom, whereas in methyl propyl ether, there are left side contain 1 carbon atom, whereas right side of oxygen atom contain 3 carbon atoms. So they both are metamerism of each other. In place of oxygen, you can also take amines, that is NH. The next one is tautomerism. Tautomerism is a dynamic equilibrium between two compounds with the same molecular formula. A carbonyl compound containing at least one alpha hydrogen atom is converted to an enol by the transfer of an alpha hydrogen onto the oxygen atoms. Alpha hydrogen is that hydrogen that is present on alpha carbon, and alpha carbon is that carbon that is present next to the functional group. So acetone, so keto form of acetone and enol form of acetone are tautomerism. The next one is ring isomerism. One of the isomer that has open chain structure whereas other has ring structure. They generally contain a different number of pi bonds in it. Propene and cyclopropane, butene and cyclobutane, pentene and cyclopentane are the examples of ring isomerism. Now try to solve this problem to make it more clear to you. Thank you.